Hello students, welcome to my channel Hans Commerce Tutorial for the lectures on commerce, accounts, finance and management. My suggestion to you, before watching the video, please go to the description below my video. You'll find a link there. Take a printout of the problems given in the link and keep it ready before watching the video so that you can be able to understand the problem, the solution and the explanation to get the maximum benefit from the lectures. Thank you. Hello students, welcome you all back to the problems of binomial distribution. So far we have completed 5 problems on binomial distribution. It's a discrete probability distribution where we can find out the probability of R successes by using the formula P of R is equal to NCR, P to the power of R, Q to the power of N minus R. So after doing some 5 problems, I think you are much comfortable in applying the binomial theorem to find out the required probability. And before starting the next problem, I hope that you all have the hard copy of the problems taken from the link under my description. So now we'll start the 6th problem. The probability that a bomb dropped from a plane strikes its target is 1 by 5. The probability that the bomb dropped from the plane will hit the target. The probability of hitting the target is 1 by 5. So we can take P is equal to probability that the bomb will hit the target. That is 1 by 5. When probability P is 1 by 5, so Q is equal to 1 minus 1 by 5. 1 minus 1 by 5 will be 4 by 5. Then find the probability that out of 6 bombs dropped, at least 3 bombs strike the target. The total number of bombs dropped are 6. We have to find out what is the probability that at least 3 bombs will hit the target. Now you can see here, P probability that the bomb hits the target 1 by 5 given in the problem. And Q is equal to 1 minus P, 1 minus 1 by 5 is 4 by 5. So if you take the LCM, it will be 5. So 5 minus 1, 4, 4 by 5. Or simply if you are not perfect in mathematics, simply subtract 5 minus 1, 4. So 4 by 5 is the Q value. Then N is equal to 6. Total number of bombs dropped 6. So according to binomial probability of R success is P of R, NCR, P to the power of R, Q to the power of N minus R. So N is equal to 6. So 6CR, 1 by 5 to the power of R, 4 by 5 to the power of 6 minus R. This is the formula we have to apply. Probability that at least 3 means minimum 3 out of 6. Total number of bombs dropped 6. Out of 6, minimum 3. 3, 4, 5, 6. We have to find out what is the probability of 3, 4, 5, 6. The probability that at least 3 bombs hits the target, that is R is greater than or equal to 3, is P of 3 plus P of 4 plus P of 5 plus P of 6. So 4 times we have to calculate probability. Or if we go by alternative method, because whenever we are given greater than equal to, we can use the alternative method also. We'll see whether it is beneficial or not by using the alternative method. P of R greater than equal to 3 is equal to 1 minus, before 3 we have 0, 1, 2. So P of 0 plus P of 1 plus P of 2. तो 3 से पहले आपके पास 0, 1, 2 है. तो ये तीनों को ऐड करके 1 में से माइनस कर देंगे. We'll get the same probability. Whether you go by this method or this method, your ultimate answer will be same. Now I'm going by the alternative method because only 3 probabilities we have to find out. So P of 0, 6C0, 1 by 5. P is 1 by 5. So 1 by 5 to the power of 0, 4 by 5 to the power of 6 minus 0. So 6C0 is 1. Already in the starting problems I told you NC0. NC0 is equal to 1. So 6C0 is 1. Then 1 by 5 to the power of 0. Anything raised to the power of 0 will be 1. Then 4 by 5 to the power of 6. That means 4 is multiplied 6 times. 4 is multiplied 6 times and 5 is multiplied 6 times. If you multiply 4 6 times, 4 into 4 into 4 into 4 into 4 into 4, 6 times, you get 4096. Similarly, if you multiply 5 into 5 into 5 into 5 into 5 into 5, 6 times if you multiply 5, you will get 15,625. So 4096 divided by 15,625, this is the probability of P of 0. Now P of 1, 6C1, 1 by 5 to the power of 1, 4 by 5 to the power of 6 minus 1. 6C1 is 6. Even if you calculate, if you apply the formula NCR, you will get 6. But remember, NC1 is equal to N. NC1 is equal to N. So 6C1 is equal to 6. 1 by 5 to the power of 1 is 1 by 5 only. Into 4 by 5 to the power of 5 minus 1, 6 minus 1. 6 minus 1 is 5. So 5 times you multiply 4 into 4 into 4 into 4 into 4. So if you multiply 5 times, you get 1024. Similarly, 5 is multiplied 5 times. 5 into 5 into 5 into 5 into 5. Then you get 3125. Then 6 into 1024, this one. 5 into 3125, 15,620. So 6144 divided by 15,625, this is P of 1. Now P of 2. 6C2, 1 by 5 to the power of 2, 4 by 5 to the power of 6 minus 2. तो 6C2 का मतलब 6 factorial divided by 2 factorial into 6 minus 2 factorial into 1 by 5 square. तो 1 square is 1 only, 5 square is 25. तो 1 by 25. तो 4 by 5 to the power of 6 minus 2. 6 minus 2 is 4. तो 4 is multiplied 4 times, 5 is multiplied 4 times. We'll get 256. 4 को 4 time multiply करो 256, 5 को 4 time multiply करो 625. Right? So 6 factorial, 6 into 5 into 4 factorial. Similar 2 factorial means 2 into 1. 6 minus 2, 4 factorial. So 4 factorial gets cancelled. 3 1s are 3, 3 2s are 2 1s are 2, 2 3s are 6. So 3 5s are 15. 3 5s are 15 into 1 by 25 into 256. So 3840 divided by 15,620. This is the probability for P of 2. We got P of 0, P of 1, P of 2. Now ultimately we'll apply in the formula P of R greater than or equal to 3 is equal to 1 minus P of 0 plus P of 1 plus P of 2. So P of 0 is here, P of 1 is here, P of 2 is here. Now take the total. Now LCM, the denominator is same for all the 3 factors. So take the same denominator, add up the numerators, you will get 14,080 divided by 15. So if you take the LCM here, so 15,625 minus 14,080, you will get 1545 divided by. These are the simple mathematics. Then if you cut 5 times, 5 से दोनों भी कट होगा, 5 3s are 15, 5 9s are 45, 309 divided by 3. The probability that 3 or more bombs will hit the target is 309 divided by 3,125. Little bit of mathematics is required, how to calculate the LCM, all these things, right? Now, 7th problem. See the 7th problem. Find the probability that in a family of 5 children, concentrate on the problem, understanding the problem is must. Find the probability that in a family of 5 children, there will be at least one boy. At least one boy. कम से कम एक boy होना. At least one का मतलब 1 भी हो सकता, 2 भी हो सकता, 3, 4, 5. Maximum children are 5. 5 children in the family. तो एटलीस्ट वन बॉय का मतलब 1 या 2 या 3 या 4 या 5. एटलीस्ट वन बॉय एंड वन गर्ल. तो मिनिमम वन बॉय भी रहना, वन गर्ल भी रहना. व्हाट इज द प्रोबेबिलिटी? Assume that probability of female birth is 1 by 2. Naturally, the probability of female birth and male birth is 1 by 2, 1 by 2, equal, right? So we take P is equal to probability that the child is a boy, 1 by 2. Then Q is equal to probability of a girl. When boy's probability is 1 by 2, girl's probability will also be 1 by 2. So 1 minus 1 by 2, we get 1 by 2. So P 1 by 2, Q 1 by 2. N is equal to 5 children. Now according to binomial probability law, probability of R successes, P of R, N C R, P to the power of R, Q to the power of N minus R. Now we apply the formula probability that at least one boy, that is R is greater than equal to 1. R is greater than equal to 1. So P of R greater than equal to 1 is equal to P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. 5 children are there. So this is the required probability, but it's a long time consuming process. The shortcut method. Instead of calculating 5 times P of 1, P of 2, P of 3, P of 4, P of 5, we can take the alternative formula. P of R greater than equal to 1 is equal to 1 minus P of 0. We'll get the same answer whether you apply this long method or shortcut method. our time is saved by using this alternative method. 1 minus P of 0. So P of 0 is 5C0, half to the power of 0, half to the power of 5 minus 0. See here, 5C0, it is 1. NC0, 1. Half to the power of 0, half to the power of 5 minus 0. Half to the power of 0 is also equal to 1. Anything raised to the power of 0 will be 1. Then half to the power of 5. So 1 is multiplied 5 times, it will be 1. 2 is multiplied 5 times, it will be 32. 2 is multiplied 5 times, it will be 32. So answer will be 1 by 32. 1 by 32 is the probability of 0. No boy child, no boy. All the 5 are girls. Then P of r greater than equal to 0 is equal to 1 minus P of 0. So 1 minus 1 by 32. If you take the LCM here 32, 32 minus 1 is 31. 32 minus 1 is 31. So 31 by 32. Or in other words, you can say 32 minus 1 is 31. 31 by 32 is the required probability. 31 by 32 is the probability that there will be at least one boy in the family of 5 children. First question completed. Second question says, what is the probability of at least one boy and one girl? So in a family of 5 children, at least one boy and one girl, what is the probability? Now this may happen in the following cases, mutually exclusive cases. What are the mutually exclusive? In a family of 5 children, at least one boy, one girl can occur in the following mutually exclusive forms. The 4 different cases are there in which we can find at least one boy and one girl. What are the cases? First case, 1 boy and 4 girls. It may happen. In a family of 5 children, it may happen 1 boy and 4 girls. In this you can see at least 1 boy, 1 girl is definitely there. Secondly, 2 boys and 3 girls. In a family of 5 children, 2 boys, 3 girls. At least 1 boy, 1 girl is there. Third one, 3 boys and 2 girls. At least 1 boy, 1 girl is there. And 4 boys, 1 girl. Again, at least 1 boy, 1 girl is there. So, the probability of at least 1 boy, 1 girl can occur in any of these following 4 cases. And all the 4 cases are mutually exclusive. Right? So, in other words, we can say, hence the required probability of at least 1 boy, 1 girl, 1 boy and 1 girl is P of 1 plus P of 2 plus P of 3 plus P of. You can see 1 boy, 2 boys, 3 boys, 4 boys. So we can take the probability of 1 boy, probability of 2 boys, probability of 3 boys, probability of 4 boys. So we add up P of 1, P of 2, P of 3, P of 4. Right? So P of 1. P of 1 is 5C1, half to the power of 1, half to the power of 5 minus 1. So 5C1 is 5. 5C1 is 5. So half to the power of 1 is half. Half to the power of 5 minus 1. 5 minus 1 is 4. So 1 is multiplied 4 times, it will be 1. 5 is multiplied 4 times, you get 16. So 5 ones are 5, 2 16 times 32. So 5 by 32 is the P of 1. Similarly, P of 2. 5C2 half to the power of 2, half to the power of 5 minus 2. 5C2, 5 factorial divided by 2 factorial into 5 minus 2 factorial. Into, see, one mathematics, one property is there. When bases are same, powers can be added. When bases are same, powers can be added. Here base is same, 1 by 2, 1 by 2, bases are same. So we can add up the powers. Here power is 2. Here 5 minus 2 is 3. So 2 plus 3, 5. 2 plus 3, 5. Half to the power of 5, already we know 1 by 32. Already we have calculated. Half to the power of 5 will be 1 by 32. So 1 by 32. 5 factorial, 5 into 4 into 3 factorial. 2 factorial, 2 into 1. 5 minus 2 is 3 factorial. 3 factorial will get cancelled. 2 1s are 2, 2 2s are 4. So 5 2s are 10. So this whole thing will become 10. So 10 1s are 10 and 32. 10 by 32 is the required probability P of 2. Now P of 3. 5C3 half to the power of 3, half to the power of 5 minus 3. So we require 5 factorial by 3 factorial into 5 minus 3 factorial. This one over. Now again half to the power of 5. यहाँ power 3 है और यहाँ power 2 है. When bases are same, powers can be added. So 3 plus 2, 5. Half to the power of 5 is 1 by 32. Half to the power of 5 is 1 by 32. So again 5 factorial, 5 into 4 into 3 factorial divided by 3 factorial, 5 minus 3 is 2 into 1. 3 will get cancelled. 2 1s are 2, 2 2s are 4, again 10. So 10 1s are 10 into 30 divided by 32. So 10 by 32 is the required probability P of 3. P of 4. 5C4 half to the power of 4 half to the power of 5 minus 4. So 5C4 5 factorial by 4 factorial into 5 minus 4 factorial into half to the power of 5, already we know 1 by 32. Then 5 factorial, 5 into 4 factorial, denominator 4 factorial, 5 minus 4 is 1. So 4 factorial will get cancelled. So 5 by 32 is the P of R. So we got P of 0, P of 1, P of 2, P of 3, P of 4. We require that one only. P of 1, P of 2, P of 3, P of 4. Now we have to add up all. So P of 1 plus P of 2 plus P of 3 plus P of 4. If you add up, denominator all same. So 32 LCM. So 5 plus 10 plus 10 plus 5. 30 by 32. Or in it will be divisible by 2. 2 15 times, 2 16 times. So 15 by 16 is the probability of at least one boy, one girl. At least one boy, one girl. The probability is 15 by 16. That's it. This is the problem number 7. Come on students, now we'll start the next problem, problem number 8. See carefully problem number 8. If 20% of bolts produced by a machine are defective, determine the probability that out of 4 bolts chosen at random, 1 or 0 or at most 2 bolts will be defective. So we can apply the binomial because the n is fixed and p remains constant. P is the probability of defective bolt. The probability of defective bolt is 20%. 20% means 20 by 100, 0.2. So we denote P is equal to probability of defective, that is equal to 0.2. Then Q is equal to 1 minus P, 1 minus 0.2 is 0.8. And N is equal to 4 bolts. Total number of bolts are 4. So you can see the solution will be like this. P probability that the bolt is defective, 20% given in the problem, 0.2. This is the probability that the bolt is defective. Q is equal to 1 minus P, 1 minus 0.2, 0.8. And N is equal to 4 bolts. So the main parameter in binomial distribution is N and P. Once if you have N and P, you can apply the binomial distribution to find out the required probability. Now, according to binomial law, probability of R successes NCR, P of R is equal to NCR, P to the power of R, Q to the power of N minus R. So we can write N की जगह पर लेंगे 4, then P 0.2 and Q 0.8. So 4CR is into 0.2 to the power of R, 0.8 to the power of 4 minus R. We'll apply this formula. First question, what is the probability that one bolt is defective? Exactly 1. How many bolts are there? Totally 4 bolts are there. Totally 4 bolts. What is the probability that exactly 1 bolt is defective? That is R is equal to 1. Simply we substitute in place of R, we put 1. P of 1 is equal to 4C1, 0.2 to the power of 1, 0.8 to the power of 4 minus 1. 4C1 is 4. 0.2 to the power of 1 is 0.2 only. 0.8 to the power of 3. Because 4 minus 1 is 3. So multiply 0.8 3 times. Multiply into 0.2 into 4, you will get 0.4096. This is the probability exactly 1 bolt is defective. Second question, what is the probability that 0 bolt is defective? No bolt are defective. All bolts are good. That is P of R is equal to 0. R is equal to 0. So P of 0, 4C0, 0.2 to the power of 0, 0.8 to the power of 4 minus 0. So 4C0 is 1. Then 0.2 to the power of 0 is 1. 0.8 to the power of 4. 4 times you multiply. 0.8 into 0.8 into 0.8 into 0.8, you will get 0.4096. Now, probability that at most 2 bolts will be defective. Now, carefully you see. Previous all the problems we have seen at least. Now it is given at most. So there is a lot of difference between at least and at most. When we say at least, it means minimum. Kam se kam. Lekin at most, maximum, not more than this. तो at most 2 defective का मतलब maximum 2 defective, not more than 2 defective. So at most 2 means it comes 0, 1, 2. At most का मतलब maximum 2. 2 से ज्यादा नहीं, 2 से कम हो सकता. तो 2 से कम क्या होगा? 0 defective bolt, 1 defective bolt, 2 defective bolt. Not more than 2. So R is less than equal to 2. When it is given at most, it means less than equal to. When it is given at least, it will be greater than equal to. At least अगर देंगा तो greater than equal to. At most अगर देंगा तो less than equal to. Here less than equal to 2. So P of R less than equal to 2 is equal to P of 0 plus P of 1 plus P of 2. Right? P of 1, P of 0 and P of 1 we have. We already calculated P of 0. We already calculated P of 1. The only thing is we need P of 2. We need P of 2. So P of 2 is equal to 4C2, 0.2 to the power of 2, 0.8 to the power of 4 minus 2. So 4C2, 4 into 3 into 2 into 1, 2 factorial, 2 into 1, 4 minus 2, 2 into 1. So 2 into 1, 2 into 1 gets cancelled, 2 1s are 2, 2 2s are 4, 3 2s are 6. So ultimately if you solve this, you'll get 6 into 0.2 square means 0.04. 0.8 square, 4 minus 2 is 2. It will be 0.64. So if you simplify, you'll get 0.1536. So 0.1536 is P of 2. So we got P of 0, P of 1 and P of 2. So probability of at most 2 defective bolt is 0.4096 plus 0.4096 plus 0.1536, 0.9728. That's it. This is the problem number 8. Now I am reading out problem number 9. A bag of 100 bulbs from a manufacturing company is known to contain 10 defectives. It is expected that 10 defective bulbs will be there in a bag of 100 bulbs. तो 100 bulbs में 10 bulbs defective हो सकते हैं. तो probability of defective bulb will be 10 by 100. 10 by 100. 100 bulbs में से 10 bulbs defective हो सकते हैं. So P is equal to 10 by 100, 0.1. If a sample of 6 bulbs is selected, N is equal to 6. What is the probability that there is at least one defective bolt? Already we have done so many problems. At least one. कम से कम एक bulb defective रहेगा. तो here P is equal to probability of defective bulb. तो 10 by 100, 0.1. 10 bulbs are defective out of total of 100 bulbs. So 0.1 is P. Q is equal to 1 minus P, 1 minus 0.1, 0.9. N is equal to 6 bulbs. According to binomial law, probability of R success is P of R NCR, P to the power of R, Q to the power of N minus R. So P of R is 6CR, 0.1 to the power of R, 0.9 to the power of 6 minus R. Then probability of at least one defective bolt. कम से कम एक. Total number of bulbs are 6. 6 में से कम एक बल्ब डिफेक्टिव रहना, इसकी प्रोबेबिलिटी है कम से कम एक, या 1 2 3 4 5 6 कुछ भी हो सकता. तो P of R greater than equal to 1 is equal to P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6. So many values we have to calculate. It's a time consuming method. So we have to go by alternative method. Whenever we are given greater than equal to, we use the alternative method. So P of R greater than equal to 1 is equal to 1 minus P of 0. 1 minus P of 0. तो P of 0 पहले मालूम कर लेंगे. P of 0 6C0, 0.1 to the power of 0, 0.9 to the power of 6 minus 0. So 6C0 is 1, 0.1 to the power of 0 is 1, 0.9 to the power of 6. If you multiply 0.96 times, you will get 0.5314. So 0.5314 is P of 0, but we need 1 minus P of 0. So P of R greater than equal to 1 is equal to 1 minus P of 0. So 1 minus 0.5314, 0.4686. So 0.4686 is the probability that there is at least one bulb defective. At least one bulb defective out of a total of 6 bulbs. That's it. This is problem number 9. Now see the problem number 10. Problem number 10 you see. In a binomial distribution, N is 5, Q is 0.4. Find the variance of the distribution. A different problem. In this problem, you are required to calculate the variance. In the theory video, I explained the characteristic features of binomial distribution. In binomial distribution, the first feature is the main parameters are n and p. So, the mean according to binomial distribution is np. N into p will give you the mean of the distribution. And variance is equal to npq. N into p into q. This will give you variance. And standard deviation is npq under root. These are the formulas in binomial distribution. So here in this problem it is asking you to calculate the variance npq, right? So here you can see in a binomial distribution n is 5, q is 0.4, variance is how much? So I have written the complete formula. Already I have explained you in the theory video. In a binomial distribution, mean is np, variance npq, standard deviation npq root, right? So p is equal to 1 minus q. Already q is given. Q is nothing but the probability of failure. When probability of failure is given, we can find out the probability of success. 1 minus q. P अगर दे दिया, q मालूम करना है, तो 1 minus p. P अगर मालूम करना है, तो 1 minus q. तो p is equal to 1 minus q, 1 minus 0.4, 0.6. So we got 0.6 is the p value. Now variance is equal to npq. So n is 5 given in the problem. P just now we have calculated 0.6 and q is given in the problem 0.4. So multiply, you will get 1.2. So variance is 1.2. That's it. This is problem number 10. Now problem number 11. Find the mean of a binomial distribution whose given by n is equal to 20 and q is 0.75. Mean मालूम करना है. So according to binomial distribution, mean is np. N into p. N is not given. Oh, sorry, n is given. P is not given. So we can calculate p because q is given. अगर q दे दिया तो p मालूम कर सकते हैं, p दे दिया तो q मालूम कर ले सकते हैं, right? So here mean is how much? N is equal to 20, q is equal to 0.75. So p is equal to 1 minus q, 1 minus 0.75, 0.25. So p is 0.25. Mean का value n into p, 20 into 0.25, mean is equal to 5. That's it. This is the problem number 11. Now problem number 12, you see. Find the binomial distribution whose mean is 9 and variance is 2.25. So we have to find out the binomial distribution. Binomial distribution means we have to find out n, p, q. All the three variables we have to calculate. Here what is given? Mean is 9 and variance is 2.25. Now see carefully. Finding the binomial distribution whose mean is 9 and variance is 2.25. The formula for mean is np. And np, mean is given in the problem 9. Variance, the formula for variance in binomial is npq. And npq is given in the problem as 2.25. Now, the formula npq is equal to 2.25 given. npq, here we have np. What is the value of np here? 9. So in place of np, I am writing 9. So 9q is equal to 2.25. q is equal to 2.25 divided by 9. या मल्टीप्लीकेशन है, इधर आकर डिवाइड हो जाएगा, तो 2.25 by 9 is 0.25. What is this 0.25? Q. Easily we got the value of Q. Now simply we can find out the value of P. P is nothing but 1 minus Q. P is equal to 1 minus Q, 1 minus 0.25, 0.75. So P आ गया 0.75. So we got P value, we got Q value. Now we need N. N is not given. So mean का formula है NP. And mean is given in the problem 9. In place of mean I am writing 9. N we don't know. But P just now we have calculated 0.75. P is 0.75. So in place of P I am writing 0.75. So 9 is equal to 0.75 into N. Now bring this N to this side. So N is equal to 9 divided by 0.75, you will get 12. You will get 12. So binomial distribution consists of N is equal to 12, P is equal to 0.75 and Q is equal to 0.25. That's all. This is the problem number 12.